Hey everyone, I'm Andrew from Box Developer Relations. Building AI agents that can interact with real-world systems doesn't have to be complex. In this video, we'll walk you through how to create a simple yet powerful agent using Google's Agent Development Kit, or ADK, that connects with Box's intelligent content platform. Through specialized tools, our agent will establish a connection to Box. This will enable it to locate and read files, folder structures, and even leverage Box's built-in AI capabilities using natural language. We'll build a Box agent that can search files, read documents, and answer questions about your content using natural language. By the end, you'll understand the core ADK architecture and how to integrate external APIs into your agents. But before we jump into our example, let's understand a bit more about why we are using ADK. And to do that, we have Lavi Nigam from the Google Cloud AI Advocacy team.
Hi everyone, this is Lavi Nigam, DevRel Engineer at Google Cloud. At Google, we designed the Agent Development Kit, or ADK, to make it much easier for developers like you to build powerful AI agents. ADK follows a clean, hierarchical pattern that makes agent development very intuitive. We know that integrating with platforms like Box is crucial, and ADK streamlines this process. The barrier to entry is low, and you'll find that developing sophisticated Box integration is surprisingly straightforward. We are excited to show you how you can leverage ADK to build amazing applications.
Exactly. So in our complete example today, we're going to build a Box agent with some really useful capabilities. This agent will be able to connect to and authenticate with Box, check the user's identity and verify connectivity to Box, search for files and folders across your Box storage, read and extract content from documents, leverage Box AI to ask intelligent questions about your documents, and at the end, we're also going to show you how we can extract structured data using Box's AI capabilities. Now, let's dive into building the tools layer. Tools are the absolute foundation of any ADK agent. Think of them as a bridge that connects your agent to external systems like Box. In our case, these tools establish a connection to Box and provide the essential capabilities to interact with files and leverage Box AI. Let's take a look at how we can create some Box-specific tools. First, we have the imports. We're bringing in several components from the Box AI Agents toolkit. These are pre-built functions that simplify our interactions with the Box API. We're importing things like Box File AI Ask for querying Box's AI, Box File Text Extract to get text from files, and importantly, Get CCG Client, which handles the authentication to Box using a client credentials grant. Now, let's look at the tools themselves. These are Python functions that our AI agent can call. For this tool, Box Who Am I tool, this one's designed to verify the connection to Box and retrieve information about the currently authenticated user. It first gets an authenticated Box API client using getCCG-client. Then it calls the client.users.getUserMe method, which fetches the me user details from Box and returns it as a dictionary. This next one, Box Read tool, this one allows the agent to read the textual content of a specific file stored in Box, given its file ID. Like before, it gets the authenticated client, and then uses the Box File Text Extract function from the toolkit, passing in the client and the file ID to extract the text. This function also handles the Box API calls needed to get the file's text representation. And for this one, Box Ask AI tool, this is where we leverage Box's built-in AI. This tool takes in a file ID and a prompt, or in other words, a question, and asks Box AI to answer the question based on the file's content. It requires a client, and then it calls the Box File AI Ask function from the toolkit. This function sends the file ID and the user's prompt to the Box AI service, which processes the document and returns the AI-generated answer. So these tools provide the agent with the necessary building blocks to interact with Box content and its AI capabilities. So, as we just saw, these tools are the building blocks. And when designing them, we followed some key principles to make them effective and maintainable. These guidelines really help in creating a robust agent. First, establish connections. You notice each tool uses getCCG client. This ensures that we have a reliable and authenticated connection to Box every single time. Second, keep functions focused. Each tool is designed to do just one specific Box operation. This makes them modular, easy to test, and reusable. Third, leverage platform capabilities. We're tapping into Box's native AI features, especially with tools like Box Ask AI Tool, which is fantastic. Fourth, use clear descriptive names. The function names, like Box Read Tool or Box Who Am I Tool, clearly tell you their purpose. Fifth, return structured data. Our tools return data in a consistent format. This makes it easier for the agent's language model to understand and use the results effectively. And lastly, handle API authentication. Authentication is centralized through the Box toolkit, so we don't need to repeat authentication in every single tool.
Thanks, Andrew. So you have just seen how to create the foundational tools that connect our agent to Box. Now, let's look at how we assemble them into a complete functioning agent called as the sub-agent and the root agent. First, let's focus on the sub-agent. This is an LLM agent, which acts as an intelligent core of our operation. It's where we combine powerful large language models with the practical tools we just built. You can see we can configure it with multiple options. For example, a model like Gemini 2.0 Flash or the latest ones which are Gemini 2.5 Flash or Pro models. Second, a name for identification, and most importantly and lastly, the tools list. This is where we plug in all those Box tools functions, making them available for the LLM to call. Now, let's look at the instructions for this agent. This is the most crucial part of the sub-agent. This detailed prompt defines the agent persona and its workflow. We're telling it that it's helpful assistance for Box, what its primary goal is, and we are explicitly listing the tasks it can perform, from identifying the user to searching folders and asking Box AI questions about the documents. So you can think of this sub-agent as a specialized Box expert. It has tools and the instruction to use them effectively. Now, next, with our specialized agent ready, we now need an orchestrator. That's the root agent. This Box agent class inherits from ADK's base agent. Its primary job isn't to talk to Box directly, but to manage the execution flow. The key method here is run async imp. In our case, the root agent's logic is very straightforward. It simply invokes our sub-agent and passes along any events it generates. This creates a clean separation of duties. And finally, we put it all together. We create an instance of our Box agent, give it a name like Box Flow Agent, and pass in the Box Full Agent LLM, which is the sub-agent we defined earlier. And we assign this to a variable called as root agent. The specific name is important, and it's what the ADK framework looks for by default to find and run your application. And just like that, we have built a complete agent hierarchy. Tools at the bottom, a smart sub-agent to use them, and a root agent at the top to manage the entire process. Building on that LLM agent example, there are several best practices to keep in mind when creating effective sub-agents in ADK. First, define connection context. Be explicit in the agent's description about how it connects to the external system like Box. Second, describe platform capabilities. Clearly highlight unique platform features the agent can use, such as Box AI integration for document intelligence. Third, write clear workflows. Your agent description should guide the LLM on the steps to take. For example, when it should search, when to read, or when to analyze document. Fourth, set behavioral guidelines. You're going to include the directives in the prompt to shape the agent's personality and responses, like telling it to be direct or make the best judgment based on the user request. Fifth and the last, use output key. And as we saw this in the code, using output key really helps maintain the conversation context, especially when multiple tools are involved. All right, back to our root agent. So we walked through the complete multi-layered structure with a dedicated sub-agent and a root agent. This is the most powerful and flexible way to build in ADK. But for many common scenarios, there's a simpler, more direct approach. Let's talk about the simpler way to create a root agent. Looking at the code in one, you'll notice we are defining root agent directly using the agent class, which is a powerful type of LLM agent. We are essentially combining the role of the sub-agent and the root agent into a single definition. All the elements we saw in our specialist sub-agent are right here: the model, the name, and the full list of our box tools. And if you look at the instructions in 2, they are identical to what we had before. We're still giving the LLM the same detailed guidance on its purpose and how to use its tool. So, you might be asking, why did we look at the more complex structure first? The reason is control and flexibility. The previous method, where we create a custom class inheriting from base agent, is what you need when you want to build a custom workflow. This gives you the power to implement a unique orchestration logic, things like conditional branching. Take an example: if the file is PDF, do this, otherwise do that. Or loops or complex state management that goes beyond the standard request response flow. However, in our case, our agent's job is to run a box export logic. The workflow is standard, and for a situation like this, ADK allows you to simplify. When your root agent's primary function is to be a main brain, let's say to reason, understand user intent, and call tools, you can define it directly as an LLM agent, like we see here. It's a powerful shortcut to the most common agent pattern. And finally, to recap, use the custom base agent approach for complex orchestration, but for direct tool using intelligent agents, this simpler method is cleaner, faster, and just as effective. So, to bring everything together, let's recap the essential for creating a solid root agent in ADK. We've just discussed 2 different approaches: the flexible custom workflow and the direct simple way. And in this slide, we'll try to summarize the key rules for both. First, and the most important, is that you have to decide on your agent structure. If you need to build a custom workflow with a unique orchestration logic like conditional steps or loops, you must inherit from a class from a base agent and then define your logic inside it. This is the path we took with our box agent example. However, if your goal is a direct, tool-driven agent, you can use the simple way which we define, and you can just define your root agent directly as an agent or an LLM agent. Now, if you choose the custom base agent path, the next 2 points are very important. You must implement the run async imp method to house your orchestration logic, and you'll use async generators with yield to manage the flow of events from your sub-agents. And finally, the last point is universal and applies to both the patterns. You must export your file instances as a root agent. This is a critical convention, as this is how the ADK command line tools discover and launch your application. So whether you're building a complex orchestrator or a straightforward intelligent agent, these are the core principles that will ensure your agent is well structured and integrates perfectly with the ADK framework.
Okay, so once your code is structured correctly, running the agent is actually quite simple. There are 2 main commands. So over here in my terminal, first, to install the necessary dependencies, we can run uvsync. This makes sure everything your agent needs is installed. Then, to start the agent, you can use uvrun ADK web. The ADK command line tool launches a web interface for you to interact with your agent. Let's now visit localhost 8000 in our browser and check it out. So imagine this scenario. In your company, no invoice gets paid unless it has a corresponding purchase order. Your company financial controller asks for your help to build something to help them find invoices without a reference to a purchase order. Again, all these files live in Box, So let's try out a few example queries to test your agent's box connectivity and capabilities. So to start off, we'll ask it the basic question, who am I? So on the screen, we see the tools used as well as the response right down below. Now let's ask it a different question. Locate my procurement folder and list all files recursively. All right, so far so good. We see the tools rendered on the screen again, as well as the response right below. It seems like it has a couple text files, as well as a folder called purchase orders. Now, with all the invoices found, let's read all of them and check out which ones actually do not reference a purchase order number. All right, it looks like box read tool was used quite a few times. And then down below, it seems pretty clear that invoice A5555 doesn't actually have a purchase order associated with it. Now, we know it must exist, so let's go ahead and find it. We'll just say find the matching purchase order. And great. Looks like after reading a few files, it found the matching purchase order, which seems like it's PO004. At this point, let's double check. Let's go ahead and read both the invoice and the purchase order so we can compare them. And there it is. So even though our invoice didn't have a direct reference to a purchase order, our agent was able to find it. You can see how the line items are matching, as well as a total for both documents.
So, as you've seen through our box agent example, building with ADK follows a very clear and powerful pattern. Now let's summarize the key takeaways for that development process. First, you start with tools. These are your foundational building blocks. As Andrew demonstrated earlier, you create focused, single-purpose functions that trap external APIs like connecting to Box, reading a file, or calling Box AI. This is how your agent interacts with the outside world. Next, you build sub-agents. This is where you combine those tools with LLM intelligence. You equip an agent like our Box Full Agent LLM with set of tools and, crucially, a clear set of instructions. This creates a specialist that knows how and when to use its capabilities to accomplish a specific goal. Then you create the root agent. The root agent is the orchestrator. Its main job isn't to use the tools directly, but to manage the sub-agents and control the overall execution flow. It's the main entry point and the brain of the entire operation. And finally, this all comes together when you structure your code. ADK encourages this clean and hierarchical separation. By keeping your tools, sub-agents, and the root agent in distinct modular pieces, you create a system that's not only powerful, but also easy to maintain, test, and scale.
Thanks again, Lavi. Overall, this modular, layered approach is really the core philosophy behind ADK, making it more intuitive to build complex, multi-agent systems. And thank you for joining us. If you want to get started on ADK or dive deeper, feel free to check out the official GitHub repository using the QR code below, or by visiting this repo directly.